All right. Thanks everyone for joining today. My name is Adam Hunter. I'm a cloud solutions architect here at Trend Micro, focused heavily on the Vision One platform. And just want to thank everyone for joining, whether it's your morning, afternoon, or evening, wherever you may be tuning in. In the spirit of Valentine's Day, which for some folks is today and also tomorrow, we basically titled the webinar Guard Your Heart, Protect Your Critical AI Assets. Without further ado, we'll go ahead and just get into the agenda, what we're going to be talking about today. So we'll start by just, talking about why Trend Micro plus NVIDIA, what is NVIDIA NIM, some of the use cases around NVIDIA NIM, what a traditional NIM AI application architecture looks like, sort of a sample of it, how Trend Micro protects NVIDIA NIM, and then how Trend Micro can provide some security context to an NVIDIA NIM-based application. We'll then have a brief demo with some attack detections around NVIDIA NIM containers and how Trend Micro detects those, and then wrap up with any questions that folks have, and we'll try to address some of those questions. All right, before we even get started, I think it also helps to just start at a high level of understanding some of the history with Trend Micro. So Trend Micro is really not new to AI. Trend Micro has been working with AI for, past couple decades now, going back to anti-spam in the early 2000s with a number of other use cases throughout the 2010s and so on. And then now today in the 2020s, where much of the focus is around generative AI and then even going forward to agentic AI. So it's helpful to just add that context in here and kind of let people know that, AI is not new to trends. So, be rest assured that you're with a very experienced organization around AI. So why Trend Micro plus NVIDIA? So Trend Micro and NVIDIA combined have about 60 years of combined experience in the enterprise space between the two companies. Trend Micro also has a deep partnership to NVIDIA. Uh, we at Trend Micro are also leading cybersecurity and setting standards around security for AI, threat intelligence, and protection. And NVIDIA is also leading the charge for real world application of AI through their hardware and software solutions. And then NVIDIA is also setting kind of the standards for AI use cases and repeatability. So that combination of, you building out your AI use cases and your AI applications, along with Trend Micro's experience around the cybersecurity to secure that AI is a great combination. So when it comes to AI, you can't really go without mentioning NVIDIA NIM in terms of containers and what NVIDIA NIM is. So NVIDIA NIM is basically an easy to use inference microservices for accelerating the deployment of foundational models that you can run on any cloud or data center, and it helps you to keep your data secure. You can look at NVIDIA NIM as basically a set of containers to kind of interface to the NVIDIA GPUs. And it's basically a pre-built container, and Helm chart provides you some industry standard APIs, allows you to basically run your AI services in your AI application architecture, which I'll get into here shortly, in a repeatable manner that gives you support, security, and all those sorts of things that you would want from a traditional enterprise AI application. Some of the use cases that NVIDIA NIM supports is, digital human for customer service, agentic AI with NVIDIA NeMo and NIM, and then a number of other things like weather forecasting, large language models, all those sorts of things. The list is pretty, exhaustive in how many different use cases, and the use cases are changing by the day of new AI applications and how you can leverage it. So very exciting space to be in, and we're happy to help customers partner on their journey in securing their AI workloads. So as we look at AI applications, right, it's good to step back and kind of look at, what does a sample AI application architecture look like? You have your users, You'll have a user interface. A good example of the user interface may be like a chat window. And then you have your application services. So you can think of these as your microservices. This is where your NVIDIA NIM containers would live. And they're talking to integration services that then talk to your data backed by APIs so that your developers could potentially build applications that are built around those application services. And then those microservices can then talk to your LLM models and your data vector databases and such. So good to kind of understand the overall kind of sample architecture. Obviously, there can be different architectures that are represented, but this is just kind of a high level to get your pique your interest around what AI applications look like and where NVIDIA NIM lives in that space. So in terms of from Trend Micro's perspective of how we secure AI applications, we look at kind of in 6 steps, right? So we have basically securing your data, securing your AI models, securing your AI infrastructure, securing your users' local AI apps, your access to AI services, and then defending against zero-day exploits. So we offer a pretty comprehensive set of features in our platform to help you in all these various areas and so that you can be successful on your journey of adopting different AI use cases and other AI technology. In terms of why this is important to also bring up is just what we're going to be mostly focused on as part of this webinar is an NVIDIA NIM and the container aspects. So where that lives is really under number 2, which is the microservices layer that could be residing in a Kubernetes cluster and has your repeatable containers within there. But like I said, we offer a full slew of other services as well that help you in that space. So if there's anything you need to do, whether you're just touching AI, crawling, or fully getting into POCs, walking or running production, we can meet you at where you're at and address your needs every step of the way. So we now know kind of where NVIDIA NIM lives, right? What it is. It's a container that helps with your AI application use cases. So how does Trend Micro protect NVIDIA NIM application architectures? We do that through the combination of Vision One container security and Vision One CREM, which stands for cyber risk and exposure management. So with the combination of those two, we can basically detect, protect, bring visibility, and then remediate any kinds of security issues that come about. In terms of container security, what that provides you really is, getting the ability to look at vulnerabilities, compliance issues in your containers, if there's any security issues that need to be resolved before they even go to production, so post or pre-deployment, sharing of policies for images, exceptions, and then any commands, and then also detecting container drift and threats. And then when it comes to more of the visibility in your attack surface, Vision One CREM can basically help you with discovering your assets. So discovering your Kubernetes clusters, your containers running in those Kubernetes clusters, viewing your attack surfaces with sensors and sources, generating insights from risk assessments, and then having automated response with AI and ML on those. So that's kind of at a high level how it protects. And then how Trend Microvision can protect NVIDIA NIM, a couple samples of some of the detections that we provide, right? So we can detect, remote code execution in a NIM container to potentially protect against model of denial of service, prompt injection attacks, insecure output handling. We can also do detection of privileged containers that are launched for potential model theft or sensitive information leakage. But then in addition to that, we can also do protections of the top 10 OWASP for LLM applications. So we have a very comprehensive platform in terms of protection. And we address the top 10, but we also have many other rules that are part of our container security offerings. So very in-depth set of features. Definitely a great solution for containers in general. In addition to that, we also align very closely to the MITRE ATT&CK framework. So all of our detections and things have the MITRE ATT&CK framework numbers associated to them. So you can be rest assured that if you're aligning your organization to that when you're looking at things from a security perspective, we definitely align closely to that. In addition, so how CREM and container security provides security context to NIM-based applications, we provide the context really by providing detection and visibility to your container infrastructure assets that could have insecure configurations. There could be data exposure in a container within your infrastructure, unapproved executions, escape attempts in the privileged containers, process attempting outbound network connectivity in your containers, and then any other infrastructure assets that could be linked to any of these above scenarios, plus many other rules and features and capabilities that are non-exhaustive that I'm not showing here, but these are most of the common ones that are some of the strength areas. So these detections can also generate what are called workbench alerts, and those can then be automated or manual remediation that can be taken by your operations staff. And just to give an understanding of what a workbench alert is, it's basically a notification from one of our detection models that indicates a potential security threat that you would want to take a look at. So, with that being said, I'll kind of pause for a second, and we're going to try to go ahead and get into a bit of a demo here. What this demo is we're going to look at basically the AWS environment with an EKS cluster, and then I'll get into the Vision One console to kind of walk you through what some of the detections look like. So I'm going to start this video now, and then I'll narrate through as it proceeds forward. So what we're looking at here is, the AWS console. I have a cluster called demo. The cluster demo has got several EC2 instances backing this EKS cluster, so Kubernetes Service Cluster. We've got several pods running in here, some being Nvidia NIM. This is being protected by Trend Micro, our daemon sets, and that's how we protect the cluster itself and have the communication go back to Vision One, our platform. What I'm going to be doing right here now is basically running a deployment YAML file, so applying that to the cluster, which sets up an Nvidia NIM container called Morpheus GPU link. I'm now showing that the deployment is running within the Kubernetes cluster, and it's running in the namespace called Morpheus GPU link. And then I'm going to go ahead and open up a text editor called Nano and show you that this deployment is running with a security context of privileged equal to true, so that you can see that as part of the YAML file. And then from there, that will generate a detection showing that someone has launched a privileged container. And I'll show you that after we get through some of the other pieces of the demo. I'm now just showing kind of, hey, the pod is running. So it's up and running based on the link to the deployment. And now what I'm going to also do for the second sample detection after is I'm going to run a shell container, which is just a Ubuntu image using port 999. And then this is just going to be running as a bash shell. So once that runs, this is going to be a second detection scenario. So that'll load up. And then in this shell, what you'll see is I'm going to go ahead and install NCAT. And so NCAT is going to provide the detection around kind of a simulated if there was some sort of a denial service attempting onto the container. So install NCAT. Okay, and then I'm going to run the NCAT just as a local just to kind of simulate as if a denial of service was hitting the container itself on 999. It's going to say connection refused, and then I'm just going to break out of the container. And then from there, basically that's the end of the demo from the AWS side of things and the Kubernetes side of things. So now what I'm going to go ahead and do is share out my screen to take us into the Vision One console. So give me just 1 second. Okay. All right. So now we're in the Vision One console. And you'll see here on the left-hand side, there's a number of different menus. We've got cyber risk exposure management, attack surface discovery. But where I'm at right now is I'm under the XDR threat investigation menu under Workbench. And this is the menu you would go to essentially to see any of your Workbench alerts that have been triggered. And these will be events that, again, are threats that are very important to understand. Hey, is there something very nefarious going on in my environment? What is that and how is it being generated? So right now I've got two Workbench alerts that have been generated. You can see they've both been generated by container security, which is protecting the containers currently, and I'll show you kind of what that looks like. But the first one really is just showing, at a high level map. Excuse me, I'm on the wrong. Let me go back to all alerts. Sorry. Uh, so the first one that we're going to look at as the Workbench alert is the NCAT. So it shows, okay, I opened up my shell. That was the container that was executed, and then I'm running the NCAT command. It shows, hey, look, it ran the command. It was using the Bash shell. I can see, you know, where that was executed. It was under the demo cluster. So I have a lot of information that I can work with, and see the exact timestamps, everything around it. It's related to a MITRE ATT&CK framework technique, so I can see what that is. And then if I needed to do any kind of execution of a playbook to do automated responses around this, I can definitely do that. I can also assign it to potentially a ServiceNow ticket or a Jira ticket. We have integrations to those. And then your operations staff could then potentially go take a look further. You can assign an owner, open a new case, and that would be a lot how you would assign that back to some of those possible places. The other Workbench alert to look at is the privileged container. So when we first we ran the Nvidia NIM container. We ran it as a privileged container. We deployed the container, and you can see again, it's providing me the information like, okay, it deployed the container. I did that under the demo cluster. Again, if I was to see that privileged container alert, I could then, do the same thing, execute a playbook, potentially have a set of automated remediation steps that happen, or assign an owner and make something happen within my operations ticketing system as well. So that being said, those are the Workbench alerts that get generated. I think it also makes sense to kind of hop into the attack surface discovery to kind of show you where the container cluster lives and resides. So if you hop into attack discovery, you go to your cloud assets, you'll see, okay, here's all of the infrastructure assets within my cloud environments, whether that's AWS, GCP, Azure, right? I have a visibility of all those. These are all being scored based on different configurations, security configurations, potential vulnerability risks, many different aspects that you'll see. In fact, might be even good to just kind of show that the scores are really reflected upon exposure, attacks, and then security configurations themselves, and that's how that gets generated. This is all done through detection models, and you can build out your own custom detection models if you wish. But just to focus in on the NVIDIA NIM container, right, to keep focus on that, we've got our demo cluster showing here. And if we pop in there, we can start to see, what are some of the risks that are going on in that cluster right now. We'll definitely see, if there's any vulnerabilities, if there's configurations, if there's privileged containers that are running, for example, container running as root. I can start to see vulnerabilities. I can start to see, what is that related to from a CVE score? And then I always have the option to, open a new case and add that to a case for, more potential remediation at that point. Additionally, you can see an asset graph of the cluster itself. So you can see kind of what's in it, what are some of the risks associated to some of the resources, and you can start to expand out. I can see, okay, here's my nodes that are here. Is there anything going on with my nodes related to those? And I can start to drill in to, some of these items as well. So a lot of flexibility if you're really threat hunting and trying to get a good understanding of your environment. It's discovering all of those aspects. So that's kind of cluster or container clusters from an attack surface discovery standpoint and workbench alerts. Now I kind of want to shift gears over to container security to kind of walk through a quick overview of what that looks like as well. So what we'll see here, if we open up Kubernetes, we support ECS and Kubernetes, as well as Microsoft AKS and Google Cloud GKE, as well as Alibaba Cloud. But the one that we're focused on here is just our demo cluster. We can see that it's showing it's got healthy protection on all of our 3 EC2 nodes that are inside our EKS cluster currently. We have runtime security, vulnerability scanning enabled, and malware scanning enabled. We can see that it's pointing to the ARN within AWS currently here, and then it's got a policy called demo policy attached to that EKS cluster. So now that we can see all that information, and if we wanted to change the policy to put it over to a different policy, we could clearly do that here. But again, it's associated to the demo policy. So you can see all of your inventory here. You can even poke into, what's running within these nodes. Is there other workloads or pods, containers? What do those look like? What are their status, et cetera? You've got all that visibility. All right, so now I want to kind of shift gears over to the container protection portion of our container security offering to kind of talk about how the policies work and what's protected. So right now, as I was just showing, you can see that the demo policy was applied to that EKS demo cluster. And basically what you have here is you have 3 sections that are applicable to your container security, right? You have policy that can be done when at deployment time. So just like when we were deploying the YAML file, that would be considered at deployment time, or it could be part of your CI/CD pipeline. Then you've got continuous, which is going to be looking at any kind of drift that happens after post deployment time. And then you have runtime, where this is looking at anything that's happening during the running piece of the containers themselves. And then lastly, we have the malware scanning, which you can schedule to do logging of the malware or put that on a schedule that you prefer and wish to have. In terms of the policies, right, you've got policies around pod properties, container properties, you've got your privileged containers. You have the ability to do either logging or blocking. So if you see something in your policy, you can log that to say, hey, look, it was ran as a privileged container. Or if it is running as a privileged container, maybe I just want to block that, right? You have the ability to do all that here. It'll also look at your image properties. So looking at any issues with any of your images, vulnerabilities, malware, secrets within those images, as well as kubectl access onto that container cluster as well. Something to keep in mind here as well that's good to mention is that this top level policy is considered a cluster-wide policy, but at any time you also have the ability to drop down and get very specific if you want to put this policy just onto a specific namespace. So you always have that option as well, and you can add as many of those as you need and see fit. Additionally, you've got some of the same settings as well for continuous. So this is like, post deployment, drift, those sorts of things. You can add those capabilities as well. And then lastly, your runtime And what this is done is how this is done is it's just done by adding a rule set. So right now it's got the demo rule set. So if we pop over to rule sets, and I'll hop off of this, we can basically create a new rule set. We could just call it test, right? Add a rule. And you can see here that all these rules that are being added for runtime rule sets are all linked to MITRE ATT&CK framework numbers, but then there's an exhaustive list of runtime rules that we have. I mean, it's very comprehensive, right? Almost 100 different rules that it can look at. You can add those as you see fit, create your policy. In our example, we're using demo. We've added all the rules. And then from there, you can simply go back to your runtime policy and add that specific rule set to your runtime. And at that point, you're now checking for those rules. You can also toggle on your telemetry on or off. And then a couple other notable mentions is, we can check for compliance, right? If you have compliance frameworks that your containers need to meet and are part of, like CIS benchmark and other compliance frameworks, we have compliance scans that can be performed on your container cluster as well. We can capture all the vulnerabilities and start to see, hey, which cluster has this vulnerability? What's that related? Which package is that related to? When was it detected? So a lot of very comprehensive levels of data here that you can look at and take action on to get a very holistic view of your security posture. In addition, if you want to see any event that's happening holistically and filter on that, maybe you're looking for something very specific, you have the ability to filter on all these sorts of categories as well. And then lastly, you've got your container image scanning if you're wanting to see how images are being scanned in your repositories for your cluster that your containers are using certain images for. You can look at any vulnerabilities that might be within those images, any malware, any exposure of secrets and such, all there ready for your visibility. So I'll stop there. That's kind of what I wanted to go over. I think it's probably a good time to see if there's any potential questions we can address. And I'd like to thank everyone for also attending. Let's see here. Did we have, it looks like didn't have any questions. So again, I'd like to thank everyone for attending. And yeah, that basically concludes the webinar.
Thanks, Adam. And we will be sending out the recording too in a follow-up email.
Sounds good. Appreciate it.